Alright, sorry about that. We're going to pick up where we left off. We were looking at number 5, and we're looking at 5a, how many grams of gold are in the ocean? So we're asked to find grams of gold. Now in this case we are going to have to find first, our strategy for solving this is to find the volume of the oceans, and then we are going to multiply the volume by the concentration. All right, and if we multiply volume by concentration, you see here we've got liters in the denominator. Volume will cancel out. It'll leave us with grams. All right, now we're given the average depth of the ocean and the total surface area of the ocean. We're going to treat the ocean like a rectangular prism here. So I'm going to say 3.63 times 10 to the 8th kilometers squared. That's my total surface area. And I need to multiply it by the average depth, which is 3.8 times 10 to the 3rd meters. Now I can't just multiply kilometers squared times meters. I have to either convert kilometers to meters or meters to kilometers. I'm just going to go ahead and convert kilometers to meters because why not? All right. So I've got 1 kilometer. We'll have 1,000 meters in it. Notice though, this is where the volume stuff comes in that we talked about before. All right, volume or area in this case. So I can't cancel out with this conversion factor kilometers completely because this is kilometers squared. In order to cancel everything out, I square my unit. Great. Square the unit, square the number associated with the unit. Here 1 squared is just 1, so that's kind of redundant. But here, whatever I do to the denominator, I have to do to the numerator. I square this unit, I have to square this number. Now that is significant. Okay, so now kilometers squared cancels out. I'm in units of meters squared. So I can now multiply my surface area by the depth. I'm in the same units now to find the total volume. So I'll go ahead and write that, 3.8 times 10 to the 3rd meters. So now my units, you've got to keep track of this. This might be a little bit hard to see. Now my units, I've got meters squared times meters. I'm in units of meters cubed right now. All right, so that's, it's the unit of volume. Great, but it's not the unit of volume that I need. In order to multiply that by the concentration, I need my volume to be in liters. So I have to somehow go from meters cubed to liters. There's all kinds of ways that you can do this, but this is the way I'm going to do. I'm going to go from meters to centimeters first. Now again, I run into this problem. This is meters cubed, because I've multiplied these two together, meters cubed. So in order to use this conversion factor, I have to cube meters, cube that number. It's essentially 1 cubed. Cube the unit, cube the number, cube the unit, cube the number. All right, now I'm in units of centimeters cubed. Again, my goal is to get to liters. Well, I know that 1 centimeter cubed is the same as 1 milliliter. I'm closer now to liters. I can go 1,000 milliliters to 1 liter. Great. Let's just make sure everything's canceling properly. Meters cubed, centimeters cubed, milliliters, milliliters. I'm left with units of liters. That's why I love doing dimensional analysis like this. I know it can seem tedious to write it out, but if you keep track of your units, it can tell you, am I multiplying things correctly? All right, so I've got liters. Now what I'm going to do, I've got my volume in liters. I'm going to multiply it by this concentration. 5.8 times 10 to the -9th grams per liter. Liters cancels out and I'm left with grams. And what I should get is 8.0 times 10 to the 12th grams. Sweet. Now if you did this step incorrectly, if you got some funky answer for this, then then you were using that answer down here in these other two problems, I still was able to give some partial credit here. All right, this whole thing is worth 3 points. All right, let's move on to part B. We're asked how many cubic centimeters of gold are in the oceans, and we're given what the density of gold is. All right, so in this case, I can take 8.0 times 10 to the 12th grams of gold that I calculated. I can use the density here. All right, I've got 19 grams per centimeters cubed. That was my density that was given. If I divide by the density, grams cancel out. I'm left with centimeters cubed, which is what I'm looking for. And I get 4.1 times 10 to the 11th centimeters cubed. Moving on to part C. We're told that the price of gold is $953 per troy ounce. We're told a conversion factor between troy ounces and grams. And we want to know what is the total value of the gold in all the oceans. Well, I'm going to start with grams. 8.0 times 10 to the 12th grams. And I'm going to my strategy is going to be grams to troy ounces, and then troy ounces to cash. All right. So I've given this conversion factor here, 31.1 grams to 1 troy ounce. And then I'm using this conversion factor here for troy ounces in money. 1 troy ounce is equal to $953. And I should get, when all's said and done, 2.5 times 10 to the 14th. A huge number, right? Worth lots of monies. Each of these are 3 points. And again, partial credit even if you started with an incorrect value here. All right, let's move on to the next page. Most people did pretty well on this page. I could tell that folks really studied their nomenclature. I was quite pleased when we were grading this section. For number 6, provide charges of the ions if they exist of each of the elements. Well, krypton's a noble gas, it's 0. Selenium is a chalcogen, -2. Phosphorus, -3. Aluminum, +3. Barium, alkaline earth metal, +2. 1 point each. All right, number 7. You are given common names and also formulas, and you need to provide the systematic name for each of these. H2SO4, sulfuric acid. This is sulfate. 8 goes to ic, sulfuric acid. All right, chalk, calcium, and this is carbonate. All right. C, baking soda. You had 2 options here. The way that I usually say this compound is sodium bicarbonate. It's kind of an old way to say this compound, but that's just what I use. You could also say sodium hydrogen carbonate. Either one would have been acceptable. All right, down here, halon 104. This is found in like fire retardant systems. So this is carbon. This is a molecular compound, so we have to name it according to those to that system. Carbon tetra, tetra from the 4. Carbon tetrachloride. All right, and down here, muriatic acid. That is hydrochloric acid. This is kind of an obscure name, but one that I still hear being thrown around in various situations. So it's worth being exposed to that name at the very least. Not something you really need to memorize. All right, now on to number 8. I had to write the chemical formulas for the following compounds. Ferric oxide is part A. Now ferric, if you remember these, the iron and copper were the ones where you needed to know that ic and us. So that's Fe3 plus. Oxide, you know, is 2 minus. So this becomes Fe2O3. Cool. All right, B, chlorous acid. All right, so ite goes to us, so we have to write chlorite. ClO2. Dinitrogen pentoxide, N2O5. Potassium nitrate, KNO3. K. Remember, potassium is abbreviated by K, not a P. Manganese 2 oxide. This 2 indicates that manganese is 2 plus. Note that the abbreviation for manganese is Mn. This is not magnesium. Magnesium is Mg. All right, this is manganese. So this is just Mn, and since oxygen is 2 minus MnO. 1 point for each of these. Alright, I think I'm going to stop with this one because I think we're approaching the limit of what I can upload on YouTube. Alright, so part 3 coming up in just a minute.